Today I will discuss first electric field questions, electric field, electric potential, and capacitor question, and later about the particle physics. So specifically, I will discuss electric field questions right now. Is it audible? My sound is clear to everyone? Is it audible? My sound is clear to everyone?
Yeah,
Okay. Okay. Which of the following unit is equivalent to farad? Farad is a unit of capacitance. What could be the answer? Question number one. What could be the answer? We are discussing electric field questions. You can mention your answer in a chat. Farad is a unit of capacitance and it is equivalent to, yeah, B is the right answer because we have the formula Q is equals to CV. So C is a charge. So C is a charge, which is coulombs, and unit of capacitance is farad and unit of voltage is volts. So this will be divided. So it will be C divided by V is equals to farad, or CV minus 1. The potential V is applied across the two identical capacitors of capacitance C, which are connected in series. Which of the following expression is a total energy stored by the capacitor? So the voltage is applied across two identical capacitors, each having a capacitance C, like and they're connected in series with each other. So these are the two capacitors connected in series with each other. The total voltage which is applied is V, and capacitance for each capacitor is C. What is the total energy stored? So what could be the answer here? The energy stored in the capacitor is equals to half Q into V. But in this question, Q and V are, Q is not given the charge, only V we have. Or in terms of capacitance, Q is equals to CV. So it is half C. If I substitute CV here in place of Q, then it will become half CV square. As the total voltage is V, so they are connected in series. So what will be the voltage across the first capacitor? It's V by 2, and voltage across the second capacitor is also V by 2 because the total voltage will divide. And if I substitute this energy in each capacitor, so energy in one capacitor, it is CV square, but V is here V by 2. So it will be half C. In place of V, I'll substitute V by 2. So it will be half C. This one is V square by 4. And this is multiplied. So it will be CV square by 8. So each capacitor is having CV square by 8. But we need a total energy. So we will sum. So if I add CV square by 8 to CV square by 8, 8 will be LCM, least count. So this will be CV square plus CV square, which is equals to 2CV square. So 2CV square by 8, when I simplify, it will be CV square by 4, or 1 by 4 CV square. So A is a right answer. Is it clear, this question? If any question, if you're not able to understand or you want me to repeat, I'll repeat the explanation. Next question, two parallel conducting plates are separated by distance d. So you can see the distance is d and the voltage is V. The potential V is applied between the plates and the charge Q is placed halfway between. Which of the following gives the magnitude of the force acting on the charge? So how we get the force acting on the charge or force experienced by the particle placed in electric field of a parallel plates? So what could be the answer for question 3? Yeah, D is the right answer, because as we know electric field is constant. So if electric field is constant, it means the force is also constant. So force on this charge does not depend on the position. Means if I place a charge at the center, the resultant force 200. If I place anywhere, the always the resultant force will be same. So we have the formula V is equals to ED, or V divided by D is equals to E. And we have the formula E is equals to F over Q. So F is equals to E multiplied by, because we have E is equals to F divided by Q. So E multiplied by Q is equals to F. E is constant, which is V over D. So we can write VQ over D. So even if the same question was there, I place a charge at this point near the positive electrode or near the negative, always because the force is constant, so it is always given by this formula VQ divided by D. This is related to magnetic field. The particle physics we will discuss, but after some time. This is related to magnetism. That this part is related to the electric field. Uh, but I will just go through the question so that you will have an understanding what happened. The photograph shows a spark coil and is used in early experiment on electricity. The diagram shows a part of the spark coil. It is using a principle of electromagnetic induction. Like what happened, we have a supply, there's a current passes through this. There's a change in a magnetic field the moment when we close the switch. So it magnetizes the iron core, and change in magnetic field of iron core will produce EMF in the secondary coil, and this will produce a spark here. So coil P is wound around the iron core. A second coil S is there, which is around P. The end S are connected to within a two thin metal, which have a gap G is there, gap between them, and known as a spark gap, because what happens when the charges move, it produces a spark. When the switch is closed, there's a current in P. When the switch is open, the large potential is produced across S, and the spark is observed across G. Basically, it ionizes the air and produces a spark. how potential difference is produced. This is related to magnetism, that there's a change in magnetic field, and due to change in magnetic field there's an induced EMF that's result in production of high EMF for NS. This is how you will there's a magnetism formulas which you will use to get this time taken. Now, the spark form when electric field strength in the gap exceed 3 exponent 6 volt per meter. So if this is the value of the electric field between the plate, between the two metal rods, then we'll see the spark. So that the air become conducting for a short time. Different spark coils produce different potential difference. The maximum size of a gap for which a spark is formed for a different potential differences are shown, like potential difference 110, 150, 190, and 230. And the maximum gaps are shown as well between the electrodes. So in the question they ask, explain how the data in the table shows that the electric field in the gap is non-uniform, means the electric field is not constant. So how the data, you have the voltage 110 kilovolts and you have the gap in centimeter. So what I can use, I can find the electric field. So what is the formula to calculate electric field? V is equals to ED. So if I need electric field is voltage divided by distance or gap between the plate. Voltage is, I will take the values, like I will take the ratio 110. Even if I did not convert the units, it will not make difference, because I'm finding that, or I want to show that it is not non-uniform or it is not constant. So when I take the ratio of the first value with, compare with the ratio of the second value, compare with the ratio of the third value, and that is compared with the fourth value, which is 230 divided by 40. So what I will find, I'll find the ratio is not constant, because the ratio between voltage and distance between the plate is refers to electric field strength or strength of electric field. So how you can use this data to confirm that electric field is not constant? So when we take the ratio, it's not same. So it shows that it is not constant. Or when two quantities are directly proportional, like as we know, we have the formula V is equals to ED. So if two quantities are directly proportional, their ratio should be constant. So V divided by E, I should get a constant result. So I'm not getting a constant result. So it is 1 mark you will get for comparing the results, like getting the answers, and the second mark you will get for reasoning, like it is the ratio is not constant. So it is not direct, ratio is not constant. So electric field is non-uniform between the plates. Sketch the electric field in the gap. So how to sketch an electric field between the gap? So this is like, once we have a positive charge here and negative charge, so an electric field is always from positive to negative. So between them it will be straight line, and then because it's a non-uniform, so that's why the gap between the lines should vary. Like near the center it is stronger, that's why field lines are closer, and then the distance between the field line increases, which shows that the electric field is non-uniform or it is not constant. Is it clear, this part? Any doubt in this one? Okay. Another circuit, this is also related to capacitor. The circuit shown is designed to test the reaction time. The following instruction will test the reaction time of a student. What happened? Hide switch S1 from the student. So we will hide the switch S1 from the student. Move S1 to a position 1 and wait until the voltmeter reads 6. Because what happened? Like if I move this to position 1, so the voltmeter is charging when it is connected to position 1. And it will charge until the voltmeter reading, the capacitor voltage is same as the supply voltage, so which is 6. Then what we'll do, close the switch S2. So we will close the switch S2. At this part you can see. And then at a random time, move S1 to position 2. So when we'll move the position to position 2, now the capacitor will act like a source of supply the charges. So the capacitor will just charge and the buzzer will ring or buzzer will sound. As soon as the buzzer sound, the student should open the switch. Like the student should open this part or this switch. So that will determine the reaction time. So use the new voltmeter reading to calculate the student reaction time. Like basically how much we first initially charge this. So when we charge this capacitor, capacitor voltage is same as the supply voltage. And we want to check the reaction time of a student. So to check a reaction time, we close the switch. And then what will happen? We move this S1 to position 2. When the moment we connect this S1 to position 2, the capacitor start to discharge. As the capacitor start to discharge, the voltmeter reading will decrease. And what student have to do? Student should open this switch so that the capacitor will not discharge. And we will use this discharge time, as we know, because capacitor discharge exponentially. So example, the original voltage is 6 volt, and a student, when he open the switch, maybe the voltage is say 4 volts. So using the formula, V is equals to V naught e raised to power minus t over RC. R is a resistance, C is a capacitance, V naught is a maximum voltage, V is the voltage which students stop the capacitor to discharge. So we can identify how much time it will take, and using this time, that's a reaction time or time taken by student to open the switch. So this is a theory of this circuit. Explain how the circuit works to test the reaction time. So how this circuit works to test the reaction time. So what will happen? Capacitor will charge when S1 is position 1, and capacitor start to discharge when S1 is at position 2, and the capacitor stop discharging when the student open the switch. And using V is equals to V naught minus T over RC, we can find the time taken by student to react to this sound, or the reaction time of the student. Is it clear? This part, how a circuit works to test the reaction time of a student? The next part, when the circuit is used with a particular student, the final voltmeter reading is 0.70. So means that's a final voltmeter reading. Show that the student reaction time is about 0.2 of a second. Capacitance is given 270 microfarad. Resistance of a resistor is 332, and resistance of a buzzer is 38. So we need a total circuit resistance. So what will be the total circuit resistance? As you can see, resistor and buzzer are connected in series when the switch S2 is closed. So it means the total circuit resistance will be the sum of resistance of resistor and the buzzer. And we will use the formula. I will not do calculation. I will just mention how we will use. So V is equals to V naught e raised to power minus T over RC. You have the V that's given in the question, 0.7. V naught is the maximum voltage, that's also given 6. R is the total circuit resistance, so that's a sum of resistance of resistor and buzzer. And C is the capacitance, which is 270 microfarad. So when you substitute, it should be in farad. So 270 exponent minus 6. Take the anti-log and find the time taken by student to react to the sound of this buzzer. Then sketch the graph of potential across the capacitor against the time when S1 is moved to position 2, and S2 is closed. So if S2 is closed, S2 is closed and S1 is moved to position 2, so capacitor start to discharge. So we have to sketch a graph for discharging of the capacitor. So how we plot the discharging of a capacitor? It will start with a maximum value, exponential decay should be there. Maximum, you can label the axis at 6 volt and then start to decrease the voltage. It will not touch the x-axis because it's exponential change. It will not touch the axis here because it does not completely discharge. Still 0.7 volts is there when the switch was open. Explain how to make the circuit more sensitive for reaction time of 0.2 seconds. You should refer to the shape of a graph in 2. So how I can make my circuit more sensitive? So what we should do to make it more sensitive? We want to make it more sensitive or it can react quickly. So the term here, more sensitive, means we want a bigger or a greater change in voltage for a given time. So what we can do to make it more sensitive? Yeah, to make it more sensitive, we will increase the resistance. So to make it more sensitive, we need a greater change in potential for a given change in time. With respect to time, it means so what we need, the time constant, if we want a greater change, so time constant is a time taken by 37% of the capacitor to discharge. The reaction time and the time constant should be approximately same, because if time constant is too small, then the capacitor will discharge instantly and we are not able to, like example, this is a capacitor for you. So using the reference of the graph, say this is a graph, but if we use, like example, this is a reaction time of the student. This discharge or the voltage should be about 37% of the original value, or the reaction time should be approximately equal to RC. If time constant is too small, then what will happen? The capacitor will discharge. and it will not able to stop. Like example, student took 0.2 second, maybe he opened the switch, but before that time the capacitor completely discharged, so it will not be accurate. Same thing, if the time constant is too big, the capacitor will take lot of time to discharge, too much time to discharge, so even negligible change in voltage will be there in 0.2 second. So this factor, the time should be approximately equal to the time constant, so that we can easily recognize the reaction time. Is it clear, this part, how we can make this circuit more sensitive for the reaction time? Like we can easily record the reaction time. Look what happened. As we know, we calculated the reaction time. The reaction time is coming out like when the circuit will be more sensitive. Look, the reaction time is about 0.2 seconds. Okay. And at 0.2 second, what was the voltage? The voltage was 0.7. The highest voltage was 6, and it was 0.7 volts. So it still means some of the voltage is there. Now what happened? If we use a capacitor with a smaller time constant means the product of RC, which is also called a time constant. What is the meaning of this RC or time constant? It means when the capacitor will discharge to 37% of its original value. Like example, if it was 6, 37% of 6 means, so this will be 6 multiplied by 37 divided by 100. So it's 2.2. So if we use a capacitor with a very small time constant, like example, if it's very small, like shorter time constant, maybe what happened, the capacitor might discharge completely. If the capacitor discharges completely, and because student is taking 0.2 of a second to open the switch again, and the capacitor already discharged before that time, so it is not accurate way to measure the sensitivity of this reaction time. Same way, if you use a very high value of a time constant, the capacitor may be or may not be able to discharge at all in this 0.2 of a second. So what we should do, the reaction time must match with the time constant, so that we can easily recognize how much time is there taken by student to open the switch. Is it clear? So the time constant should not be too big, it will not be accurate. The time constant should not be two values are there. One is the term time constant, which is RC. Another one is a reaction time. So the time constant should not be too small compared to the reaction time, because what happened, a student is taking 0.2 of a second to open the switch. So, but before opening the switch, if the capacitor is completely discharged, then there is no use of opening the switch. So that will not be accurate. And same thing, if we calculate the time constant, if it's too big or high value of a time constant, maybe the capacitor is not able to discharge at all when the high value of a time constant. So both ways it will not work. It will work when the time constant, which is RC, matches with the reaction time of a student. So when it matches with the reaction time of the student, capacitor will discharge approximately 37% of its original value. So we can easily recognize the voltage. So this required the time constant to be closer to the approximate reaction time. If time constant is too small, the capacitor will approximately nearly discharged, and if time constant is too large, then the capacitor will take lot of time to discharge. And what we can do, because here the reaction time is 0.2 seconds, and at when the reaction time is 0.2 second, the voltage was 0.7 volts. So what I want it to be same as like a time constant. So original voltage is 6 volt. Time constant is about 37% of original value, which is 2.2 volts. So I want this to discharge when the reaction time approximately matches with the time constant. So time constant should be 0.2 second. But when I multiply R with C, multiplying R with C is not 0.2 second, it is smaller than that. That is why I should use higher value of resistance and higher value of capacitance until it matches with the reaction time of the student. It should not be too high, it should not be too low. Is it clear now? So this was the question. Next is related to the particles. Another paper I'll share with you. This is January 2018. Question 3. What could be the answer? Question number 3. Yeah, what's your answer for question 3? D is the right answer. How you can work out, because the energy stored in the capacitor is equals to half Q into V. Then as we know, because either Q is equals to CV, so I can substitute Q is equals to CV. If I substitute Q is equals to CV, then energy will be half. If in place of Q, I'll substitute CV. So energy will be equal to half CV square. So half CV square, none of them matches with half CV square. Then there's also another way. V is equals to Q divided by C. So if I substitute, energy is half Q into V, and V is equals to Q divided by C. So energy is equals to half Q. In place of V, I write Q over C. So when we multiply, energy is equals to half Q square by C. So which one it matches with? It matches with D. So there are three formulas to get the energy of the capacitor: half QV, half CV square, or half Q square by C. The potential across the charged capacitor is V naught. That's the maximum voltage. The capacitor discharged through a fixed resistor after a time equal to the time constant. So time taken by capacitor to discharge is same as the time constant. What is the potential? the potential has reduced to V. Which of the following is the correct expression for V? Which of them is the correct expression for V? So it's a simple, as first you write the equation for discharge of a capacitor. So as we know that V, the voltage after a certain time interval, so V is equals to V naught e raised to power minus T over RC, or V is, they mention in the question, after time equal to the time constant. So means this is the time and that's equal to time constant, or both have the same value. So both have the same value, their ratio will be 1. So V naught e raised to power minus 1. And if it is minus 1, I can move this into denominator. So I can write e raised to power 1. So which one it matches with? V is equals to V naught e raised to power 1. So it matches with option B. Which of the following is a unit of permittivity of the free space? Like how much free space allow? So we have this formula. This is related to Coulomb's law. According to Coulomb's law, F is equals to KQ over uh, F is equals to K Q1 Q2 over R square. So we have the formula for Coulomb's law, the force between the charges. F is equals to K Q1 Q2 over R square. And what is this K? K is equals to 1 upon 4 pi epsilon naught, which is called a permittivity of the free space. So in place of K, I can write 1 upon 4 pi epsilon Q1 Q2 over R square. But I need epsilon, unit of epsilon. So epsilon will be equal to Q1 Q2 divided by 4 pi F into R square. Now what is the unit of Q? Q is a charge. So Q1 is also a charge, Q2 is a charge. So both are charges. So charge multiplied by charge, it will be Coulomb square. 4 and pi are the constants, so it does not have any unit. Force is Newton, the SI unit. And then it is meter for distance and square. So if we simplify this, what we will get? We'll get Coulomb square, Newton minus 1, meter minus 2, or meter minus 2, Newton minus 1. So which one it matches with? It matches with B. I'll read the question because otherwise I have to zoom out. The following circuit is used to charge a capacitor. Which of the following pair of the graph shows a variation of a current in the resistor with time and variation of a charge stored in the capacitor with respect to time? The capacitor, you can see, is used to charge a capacitor. We are charging a capacitor. So what could be the answer for current? And what could current time graph and charge time graph for charging a capacitor? What's the answer for question number 8? Yeah, which pair represent? B is the right answer, because what happened when the charges are passing through the capacitor, as the capacitor start to charge, it blocked the charges to flow. So the current always reduced. The charging and discharging current are always reduced. But what happened? The capacitor is storing the charge, so charge start to increase, but the current start to decrease. Current is a flow of the charge. As there are more charge on the capacitor, it block the flow of the charges. That's why the charge stored on the capacitor increase, whereas the movement of the charge through the resistor decrease, so the current will decrease. So B was a right answer. Two charged spheres of equal masses, so they have the equal masses, suspended with insulating thread of equal length. One sphere has a charge of Q and the other has a charge 10Q. Which of the following shows the arrangement of the sphere when they are in equilibrium? Means when they balances each other. What is the right answer? A, B, C, or D? Keep in mind they have the equal masses. The correct answer is C. Why the correct answer is C? Because even this is a 10 coulomb charge and this is 1 coulomb charge, but the force between them is same, because the formula is F is equals to K Q1 Q2 over R square. So the force applied by charge, the force experienced by charge 10 coulomb is same as force experienced by charge 1 coulomb. So if this is experiencing 10 Newton, this also experience 10 Newton. And in the question they specify both have the same mass, so they will have the same displacement from the equilibrium position. That's why C is the right answer. Is it clear? You should focus on this word equal masses. The photograph shows a Van de Graaff generator used in a school. In a Van de Graaff generator, a charge is transferred to a hollow metal which is insulated from the ground. The dome may be treated as a positively charged sphere with a charge distributed evenly on the surface, and the electric field outside this dome, the electric field outside the sphere is same as if we charge, if the charge were concentrated at the center. This is like a hollow sphere we discussed. Suggest why there is no field lines inside the sphere. Why there are no field lines inside the sphere? What's the reason? So resultant force is zero, or there are no charge inside the sphere. That's why there are no field lines here, because there is no, or even the resultant force is zero, means the charge, there is no net force here, because you have the formula E is equals to F over Q. If I place a charge here, this charge if I place electron here, this electron will not experience any force inside this, because all the charges cancel out the effect of each other. So this electron will not experience any force. So if force is zero, the electric field is zero. So there are no field lines within the sphere. Then sketch a graph to show how the electric field strength vary with the distance from the center. This is a radius. So this is a radius. After radius, the electric field strength within the sphere, there is no electric field. And after that, the electric field will vary. And we know for a point charge, the variation of electric field is equals to kq over r square. So it follow inverse square law. So when we sketch, it will be a curve. And it follow inverse square law. So greater variation in the beginning and then gradually reduce. The capacitance of a conducting sphere of radius r is given by c is equals to 4 pi epsilon r. The dome of Van de Graaff behaves as a conducting sphere of 12 centimeter, radius 12 centimeter. The charge on the dome is 1.5 exponent minus 6. Calculate the potential across the dome. So dome and the earth. So how we can calculate the potential across the dome and this earth? So first we have the charge, we have the distance. So using a formula, Q is equals to CV. So the charge is given, but how to find capacitance? The capacitance, the formula is given for the capacitance. That's 4 pi epsilon r. The value of epsilon, what value you will take? You can check the constants at the last. So value of the epsilon is also given. Permittivity of the free space 8.85 exponent minus 12. So using this, you will find the potential or the voltage which is developed between the dome and the Van de Graaff dome and the earth. The dome of a Van de Graaff generator is connected to earth through a resistor R. Calculate the time taken for Van de Graaff generator to lose 70% of its original charge. So how we'll get the 70% of its original charge? This is the maximum charge the dome can have, which is 1.5 exponent minus 6. Or you can also use this formula. You have Q is equals to Q naught e raised to power minus T over RC. So 70% of its original charge, or I can say 0.7 Q naught. That's the same thing, because 70% of Q naught is equal to, in terms of decimal, it is 0.7 of Q naught. So in place of Q, I can write 0.7 of Q naught. This one is a maximum charge. So without substituting, I can cancel out this e raised to power minus T. T is the time which I'm finding. R is the resistance through which it discharged, 9.1 exponent 11. And C is the capacitance, which we will work out from the previous formula. And so we'll substitute, take anti-log. We'll substitute this value of the capacitance, take anti-log, and you will get the time taken by this capacitor to discharge 70% of its original value. Is it clear? But in the question, just one more point, because I mentioned 0.7, but it is written a time taken by Venn diagram generator to lose 70% of its charge. So if it lose 70% of the charge, then how much charge will be left? 30% will be left, because what we substitute in the formula, Q is equals to Q naught e raised to power minus T over RC. It is not what is discharged, it is what is left. So how much charge is left? If 70% is discharged, so 30% is left on it. So that's why I'll not substitute 0.7. I thought it was written that the charge is when the charge is 70%, but this word is important because it lose 70%. So how much charge is left? 30% is left. If it lose 70%, so the charge left is 0.3 Q naught. And the remaining, the rest you will do in the same manner, but keep this in mind. It's lose 70%, not when it is having 70% of its original charge. Is it clear? Instead of substituting 0.7, it should be 0.3. Any doubt in this part? This is about electromagnetic induction and magnetism. Another paper. This is January 2017 paper. Okay, a teacher state that the repulsive force between 1 coulomb of a charge on the ground and 1 coulomb charge on 1000 kg mass is large enough to support the mass when it is 1 kilometer above the ground. Determine whether the teacher is correct. So basically, what happened, like example, if two identical charges are there, like there's a 1 coulomb charge which is on the ground, and there's also 1 coulomb charge on the mass which is 1000 kg. So like charges are there, they will repel each other. So the electrostatic repulsion must balance with the weight to levitate this charge, or it should be higher enough to lift this charge or move this charge. So whether the student, whether the teacher state a repulsive force is enough to support the mass when they are 1 kilometer away. So the distance between the two charges is equals to 1 kilometer, but SI unit is meter, so it should be 1000 meters. So I will use the electrostatic force. I will find F is equals to K Q1 Q2 over R square. So K, the value of the K is 9 exponent 9, or I can, if you don't remember, you can also work out by using a formula 1 over 4 pi epsilon naught, and epsilon naught value is given in the constant. So you can find value of a K. Otherwise, just if you remember 9 exponent 9, that's also correct. So 9 exponent 9 multiplied by 1 multiplied by 1, and the distance between them is 1000 square. What's the electrostatic force when you solve this? 9 exponent 9 divided by 1000 square. What is the electrostatic force? So it is 9,000. And when you calculate the weight, so this is coming out 9,000 newtons, the electrostatic repulsion force. And what about the weight? Weight is mass multiplied by gravity. So mass is 1000 and the gravity is 9.8. When I multiply 1000 with 9.8, what I will get? So is it enough to balance 9.8 multiplied by 1000, which is equals to 9,800. So you can see the weight is higher. The weight is 9,800 Newton and the electrostatic force is 9,000. So means this force is not sufficient or enough. The electrostatic force or repulsion is not sufficient to support this mass of 1000 kilogram. So here whether teacher is correct. So in this case, the statement, is it not true? It is not true because the force, electrostatic force of repulsion is less than the weight. Okay. The timer circuit include a capacitor and a variable resistor. They are connected in series. The graph shows how the current in the timer circuit vary with the time. When the capacitor discharged through a variable resistor, the resistance of a variable resistor is 8.2 kilo ohm or 8,200 ohms. The variation is shown. Show that the capacitance of a capacitor is about 0.02 farad. So how we can work out, and it's of 3 marks. So we can use this graph, and using this graph we can work out the time taken by capacitor or the capacitance of the capacitor, because it's a current in time graph. So we have this formula, I is equals to I naught e raised to power minus T over RC. That's a formula. So what is I naught? I naught is the maximum current. Keep in mind these units because it is written in milli. So when you substitute the value, it should be not in milli. So what's the answer here? This looks 2.4. So 2.4 milliampere. So maximum current or I naught is 2.4 into 10 to the power minus 3 ampere. Then what is I? I is the current after certain time interval. So it's up to you. Any current you can take. I will take a simple value so that it will make easy for calculation. So I took time 50. So when I took time 50, the current was how much? Between 1 and 0.5. So it is 0.75 milliampere. So this I is equals to 0.75 milliamperes. So we have I naught, we have I. What is R? R is given in the question. It is given 8.2 kilo ohm or 8,200. What is T? T is a time. Like after certain time, what is the current? That's the time T, which we work out. Time is in seconds, so we'll substitute 150. So we just have to find the capacitance using this equation. We will find the capacitance and we have to show it is 0.02 farad. Is it clear? So using the graph, you can work out the capacitance of this capacitor. For the next part, calculate the initial charge on the capacitor. So how we can find the initial charge on the capacitor or the maximum charge on the capacitor? So we have the formula Q is equals to CV. So if I know the capacitance because we worked out in the previous part, which is approximately 0.02 farad, then I need a voltage. So how I can find the voltage? So I will find the maximum current or the starting current is there. So we have the formula V is equals to IR. So I have the maximum current, the starting current. I know the resistance. So I will find the maximum voltage of the capacitor. So after getting the maximum voltage, I will substitute in this formula Q is equals to CV. So I will know what was the initial charge or the charge in the beginning on this capacitor, or the maximum charge which was present on this capacitor. Is it clear? Then energy stored. To get the energy stored, energy, we can use different formula. So E is equals to half Q into V. So we already know the maximum charge. We know the maximum voltage. Divide by 2, what we'll get? We'll get how much energy stored on this capacitor. Another timer circuit. Another timer circuit. The capacitance is 470 microfarad. That's another timer circuit is there, which is having a capacitance of 470 microfarad. The circuit is switched off when the potential falls to 15% of its original value. The variable resistor is adjusted so that the timer circuit switch off after 3.5 minutes. Calculate resistance of a variable resistor. So how we can find the resistance of a variable resistor? So we have this formula V is equals to V naught e raised to power minus T over RC. Because the voltage is given, that's why we are using this formula. V is equals to V naught e raised to power minus T over RC. And they mention the potential falls to 15% of its original initial value. Like if initial value is V naught, after this time, after 3.5 minutes, it falls to 15% of original value, so it becomes 15% V naught. So what we'll substitute here, 15% V naught, or I can substitute 0.15 if I convert into decimal. 0.15 V naught is equals to V naught e raised to power T. The time should be in seconds, so I have to convert this 3.5 minutes into second. So I'll multiply by 60. C is the capacitance, which is given 470 microfarad, and R is the resistance of this circuit. That's R. So using this, V naught will cancel with V naught. We'll take anti-log and solve, get the resistance of this capacitor. Is it clear how we worked out the resistance of this capacitor? Any doubt in this part? So a similar pattern you will find when you're solving a question related to capacitance. Okay, in this question, the diagram shows a part of an electron deflection tube. You have a vacuum, 2 electrodes are there, an electron beam hitting a fluorescent screen. When this electron beam hit the fluorescent screen, that point will light up or give a light. 2.1 kilovolt is applied, and but between the two electrodes, the voltage is 12 volts. The electron gun consists of a hot metal and a positively charged anode. What is the purpose of this anode? It's a collimate the beam, because what happen, electrons will come out in all the direction. It focus them so that they will move in a straight line. How this produce a beam of electron? So how this part produce a beam of electron? Just I mentioned that. So electrons which are emitted from the metal, so they are accelerated or attracted towards the anode or a charged positive plate, which make a beam of electron. Because what happened, as you can see, electrons are accelerated coming towards this, but electrons which are closer to the surface will stop at that point. Only the electrons which are exactly at the center, they will experience the same force from both sides, which cancel out each other. That's why we'll have a beam of electron coming out through this electron gun. The next part, the potential between the hot metal filament and the anode is 2.1 kilovolt. Calculate the velocity of the electron as they leave the electron gun. So what is the velocity at which these electrons leave the electron gun? So basically, electrical energy is converted into kinetic energy. And how we can find the electrical energy? Electrical energy is voltage into charge. In this part, the electrical energy is used to accelerate the particle. So we can say the electrical energy is equals to kinetic energy. Electrical energy, voltage is work done per unit charge. So work done is voltage into charge. So we have the voltage, which is V, and Q is the charge of electron. And kinetic energy is half mv square. This V is the velocity. So I'm using a slightly curve. This V is for potential or the voltage. So we have the voltage. We know the charge of electron, which is 1.6 exponent minus 19. We know the mass of electron, that is 9.11 exponent minus 31 kilogram. So we can work out the speed at which this electron will come out from the gun. Is it clear, this part? The constants, you don't have to memorize the charge or mass of electron. It is given in the at the last as the constant, but if you remember, that's well and good. So you can solve in a short time. Is it clear, this part? Now, the electron beam passes between the two electrodes. The potential has been applied, means we apply the voltage here. These plates, we apply the voltage. So what we observe, electron, because if this is top side is positive, electron will go up. If downside is positive, electron will go down. In the beginning, there is no potential, so electron was moving in a straight line. On the diagram, sketch an electric field. As you can identify, you can see this is a movement of electron. Electron are negative, so they're attracted towards positive. So it means this plate is the top plate is a positive and the bottom plate is negative. And as we know, electric field lines between the plates, it is uniform or constant. So you should make parallel lines equally spaced, and near the edges, it will be curved. But between the plates, it should be uniform or constant. Even you are drawing a parallel lines, if you're drawing a parallel lines, but you're not drawing them equally spaced, then it is not considered as correct, because if you draw parallel lines but they are not equally spaced, then this is wrong. Why it's wrong? Because the distance, the gap between the field lines show the strength. If you are drawing different lengths between the field lines, or the gap between the field lines is not uniform or constant, it shows that the strength of electric field is variable, it is not constant. But between the plates, there is a constant electric field. The voltage of 550 is applied across the plate, another deflection tube, and the vertical separation is 5 centimeter of the plate. Show that the electrostatic force of attraction between the plate is about 2 exponent. So we have the voltage, we have the distance. So how to find E is equals to F over Q? So force is equals to E is equals to F over Q. So F is equals to E multiplied by Q. The electric field strength is given. Sorry, the voltage is given. So you can work out the voltage. V is equals to ED, or E is equals to V divided by D. So you'll find the voltage is given 550, spacing is in centimeter, convert into meter, which is 0.05. So you will get electric field. After getting electric field, because we are talking about the force on electron, so charge on electron is 1.6 exponent minus 19. So we can work out the electrostatic force which this electron will experience, equal to 2 exponent minus 15 newtons. Is it clear? The electron in the beam enter a region with a horizontal speed of 2.2 exponent 7. So means when this electron enter, it was having a speed of 2.2 into 10 power. It was 7 meter per second. This was the speed of this electron. So 2.2 exponent 7 meter per second is the speed of this electron. So when this electron enter, as it is deflected, so now it shows it has two components. The horizontal component is there for a speed. It's like a simple, it's like a motion under the gravity, the projectile motion. So now it has two components. What are the two components? There is a horizontal component of the velocity and there is a vertical component. Vertical component, there is acceleration due to the electric field. Horizontal component, there is no acceleration. It continues to move with the same horizontal speed, but the vertical speed changes due to the electric field. And what is the vertical speed? This is the horizontal speed. So what is the vertical speed? The vertical speed is 0. And it start to increase as it is moving towards the electrodes. So we can work out, determine the vertical deflection of the beam after traveling 10 centimeter horizontally. So example, these are the plates, okay? This is how the beam is moving, beam of electron. As it entered, it was having only horizontal, but it is changing. So they're saying when it covered 10 centimeter, if it covered 10 centimeter horizontal distance, we have to calculate the deflection. Vertical deflection means we need this. So first what we will do, we have the horizontal speed, which is 2.2 into 10 power 7 meter per second. So using this speed, we will find how much time it will take to cover this 10 centimeter. 10 centimeter, or you will convert into, so speed is equals to distance over time, or time is equals to distance divided by speed. So distance 10 centimeter or 0.1 meter divided by the speed, which is 2.2 exponent 7. After we'll get the time, we'll know how much time it will take to cover horizontally 10 centimeter. Then we will find, because we need this vertical displacement, so we will use the formula. What we can use S is equals to ut plus half at square. Why I'm using equation of motion? Because in a vertical part there is acceleration. What is the initial velocity? Initial vertical velocity is 0. So this whole factor will be removed. So what we are left with, S is equals to 1 by 2 at square. T is the same as this one. Why? Because how much time it will take to cover horizontally, same time it will take to cover this vertical distance, S. But what about acceleration? How I can find acceleration? I have the formula F is equals to ma. So A is equals to F divided by m. F already we worked out in the previous part, the force experienced by the electron, and m is the mass of electron. So I will know what is the acceleration. So I'll get the acceleration. I will substitute the time, divide by time square, divide by 2. What I will get? I will get this vertical displacement or vertical distance. Is it clear? Discussion? Or you want me to repeat? Okay. This one is January 2016 paper. The unit of the capacitance is farad. The farad can also be written as, what could be the answer for this question? January 2016 paper. Farad can also be written as, look, how you can work out, you have the formula Q is equals to CV, okay? Yeah, A is the right answer. And how you can work out, you have the formula Q is equals to CV. And so Q divided by Q divided by V is equals to C. Q is the charge, and charge, because as you can see, ampere is given. So charge is given in terms of current and time. So as we know, current is charge divided by time. So charge is equals to current multiplied by time. So in place of charge, I can write current multiplied by time divided by V. Current is ampere, time is second, divided by V. If I move to outside numerator, A will be the right answer. Which graph shows the electric field strength due to a negative point charge vary with the distance r? Electric field strength E is equals to kq over r square. That's a variation of electric field strength due to a point charge. So what could be the right answer? And negative. Yeah, D is the right answer here, because uh, both are showing inverse square relation, but one is for positive, electric field of positive charge is outward, negative inward. That's why this is for specifically for negative point charge. two charges, capital Q and small q, are located as shown in the diagram, which is point X is halfway between the two charges. A small positive charge move from plus Q to minus Q. Means a small positive charge is moved from plus Q to minus Q. Which statement about the resultant force on this charge as it passes through point X is correct? These are not two parallel plates, these are the charges. So which statement is correct here? No, as it passes through X. Not X, as it passed through the X. Look, these are, one is positive charge, another one is negative charge. The magnitude of the resultant is, when it passes through X, it is minimum. B is the right answer. When a positive charge passes through the center, the magnitude of the resultant force, not about force, it's about resultant force. That force will be minimum. What you can do, you can solve this to understand this question. You can simply take, say a distance is there, say 1 meter, okay? And you place a positive charge at 0.25, means at this point. So or you place it at this point. So this is 0.25, this will be 0.75, okay? Or this will be 0.75, 0.25, and the other one will be 0.75. But when it is exactly at the center, you can see the force between the charge, how it vary. F is equals to K Q1 Q2 over R square. When it is at 0.25, if we increase the distance, so distance is double. If distance is double, how the force will decrease? Force will decrease by 4. So the force at this point, when it is exactly at 0.5 meter, either from A or from or plus Q and minus Q, the decrease in force is much greater as compared to any other point. And the resultant force is F1 plus F2. So it's better you use the value, and using the value you can work out. Or simply you can understand from the idea that when it is at this point, it is closer to Q, it is away from R, but because it is closer to Q, so there is a greater repulsion. Same way, when it is closer to minus Q, there is a greater attraction and less repulsion. But when it is halfway between the two, so there is a weak repulsion and there is a weak attraction. So what will be the resultant force at this point? The resultant force will be minimum. Is it clear? Why at the center resultant force is minimum? Because at this point it is very close to a negative charge, so greater attraction, less repulsion, resultant force is there. At this point, greater repulsion, less attraction, but resultant force is higher. But at this point, small repulsion and small attraction, so resultant force, which is a sum of the two forces due to plus q and minus q, that will be minimum or small amount. Is it clear, this part? Question number 4, why the answer is B. Resultant force is not zero. Why? Because the two forces are acting in the same direction. If it was opposite direction, then like if this was plus q and minus q, then at this point the resultant force will be 0. And you can see, if I say draw electric field line, so you can understand from drawing the electric field line, this is how we draw electric field line between the two oppositely charged particles. So you can see near the charges, electric field lines are closer, so stronger force. But at the center, the gap between the lines is more, so the force will become minimum or smaller. And exactly at the center, the force will be very small. There will be a force, but a small force. Question 5. What could be the answer for question 5? Question number 5. You have the voltage and you have the separation. You need E. Yeah, question 5C is the right answer. Some lights are designed to dim gradually after being switched off. You can find these type of lights used in cars as well. Like when you close the door, gradually the light will be dim. This can be done by using a capacitor in a timer circuit. The circuit diagram shows how the potential difference can be supplied across a resistor for a limited time. At position A, the capacitor will charge, and at position B, the capacitor discharge. When the switch is at position A, the capacitor charges. In terms of movement of electron, explain what happened to capacitor as it become fully charged. So what happened to capacitor as the capacitor become fully charged? So when the charge, what happened first, the electron will move from the battery to the plate of the capacitor. So when the capacitor is fully charged, there is no movement of the electrons or the particles, or the rate of electron flow decreases, and eventually it will stop when the voltage of the battery is same as the voltage of the capacitor. Calculate the energy stored in the capacitor. So how to get energy? You have the voltage, you have the capacitance. So energy stored in terms of voltage and capacitance. So half Q CV, Q is equals to CV. So energy is Q into V. So in place of Q, I can write CV. So it will become half CV square. C is the capacitance, 4,700 microfarad, and the voltage is 12. So I can just substitute and I will find the energy. The switch is moved from position B and the capacitor discharged through resistor. Describe what happened to current through the resistor. So what happened in the beginning when we connect, when the capacitor is completely charged and we connect to position B, capacitor start to discharge. When it start to discharge, what we will observe, that there is an exponential decrease in the current over a time, because capacitor, there's always exponential decrease in voltage or current or charge when the capacitor charge or discharge. The switch is more, this we did for the circuit shown, the potential across the capacitor fall to 10% of the supply, like that's a voltage which is there now after 25. So we have the formula V is equals to V naught e raised to power minus T over RC. C is a capacitance which we know. What is V? It's 10% of the supply, it falls. So means it is 0.1 V naught is equals to V naught e raised to power minus T, which is 25 R, and the capacitance is 4700 microfarad. So 4700 exponent minus 6. V naught will cancel with V naught. So this is 0.1 is equals to e raised to power minus 25 divided by R into 4700 exponent minus 6. To remove this e, I will take log both sides. So ln 0.1 is equals to ln and e are anti-functions, so cancel out. It will be minus 25 divided by R into 4700 microfarad. So I need R. So just I will simplify. I will get the value for R. The mass spectrometer is a device which is used to identify atoms by measuring the mass to charge. The ionized atom in a vacuum is accelerated by electric field. The potential V is applied. The ion has a mass accelerated. Show that the mass to charge ratio of ion is given by this. So basically, how we can show this? As we know, we are accelerating the electron or the charge by using the electric field. So we can say electrical energy is equals to kinetic energy. So electrical energy is equals to kinetic. Electrical voltage is energy into voltage is work done per unit charge. So voltage into charge is equals to kinetic energy half mv square. And we can just substitute the values here, as you can see, because we need a potential. So this 2 is divided, other side it will be multiplied. So it will be 2vq is equals to mb square. Or I need m divided by, so I need m divided by q. Just I rearrange the equation. I can say, don't cancel this voltage with this. This is velocity v. So better use capital V for voltage and small v for velocity. I need mass to charge ratio. So mass divided by charge is equals to 2 into voltage divided by v square. So you can see it's a similar ratio. The magnetic field one is there. So that's related to magnetism. That's why I skipped. We are only discussing the electric field questions and capacitors. Okay, so this was the last question. So we discuss electric field questions to clear the idea about how the questions are there and how you will solve. Next class, we'll discuss the particle physics question. I will explain accelerators first, and then we'll discuss particle physics. Any doubt related to the class today? So I'll end the session now and share the recording with you.